Yo, big ball. Yeah. Oh, man. Why does it keep slipping? Yo, one more time, man. Give me the ball. What's wrong with these shoes? Oh, it slipped again! Why me? Why am I slipping? Why is the ball slipping? Man. Who's that? Wow, he's good, man. The ball's not even slipping through your hand, and he doesn't even slip anywhere. Why can't I be like that? Why do I keep slipping everywhere? Let's go check out what this guy is. Alright, 45-degree angle shot for the furthest range. Yo, can I help you? I'm trying to play. Hey man, you're really good. Whenever I try to catch the ball, it goes right through my hands. Whenever I try to make a good cut or anything, I slip and I fall. Man, obviously you're gonna slip. The coefficient of friction between your shoes and this ground is like 0. What are you talking about? Okay, the coefficient of friction tells you how slippery one object is onto another. Like, see right here? It doesn't slip because the coefficient of friction between my shoes and the ground is high. See, your shoes aren't designed for basketball, where my shoes are. The material on the bottom of my shoes creates friction with the ground, and that frictional force prevents you from slipping. The material on the bottom of your shoes doesn't create that frictional force, and that's why you're slipping. Check this. Let me try, man. Alright, I get that, man. Why does the ball keep slipping out of my hands? It's the same idea of friction. That soccer ball isn't designed to play basketball. The material on that soccer ball has a very low coefficient of friction when it comes in contact with your hands. The leather material on this basketball has a high coefficient of friction when in surface with your hands. That frictional force slows the ball down when it comes into your hands, and it's easier to catch and easier to control. So every time you shoot, it goes in. Alright, yo, now that you understand the frictional force involved in basketball, try catching this. I actually got it. Wow, the development in technology for basketball really creates more friction, easier to catch it. Yeah. Oh, so cool. Whoa. Where's the physics in that? Oh, yeah. Sorry about that, yo. Watch my shot now, watch my shot.
Yo, you okay? Wake up.
Oh yeah, I just saw the worst shot ever.
I kinda need some help with my shot too.
Ever heard of projectile motion? Now that's the deal. Remember the angle 45 degrees? That's your new best friend.
How's it going, 45 degrees?
45 degrees is the angle at which you must shoot for maximum range. As the angle of your shot gets below 45 degrees, your ball will go further, but it will not go as high. As the angle of your shot gets above 45 degrees, your ball will travel a higher height, but the distance of your shot in the horizontal axis will be shorter.
Oh, that makes sense now. So, when you shoot below 45 degrees, the initial velocity of the ball is more in the X direction than in the Y direction. And when you shoot above 45 degrees, the initial velocity of the ball is more in the Y direction than the X direction.
Alright, rookie! Nose for your nose and your shot!
Okay, so first I'll try shooting from right here.
Okay, so you're pretty close to the net, so tell me, do you want the ball to travel a high height but a short distance, or do you want the ball to travel a long distance but a shorter height?
So the net's not too far away, and I don't need to travel a long distance. So therefore, I'm gonna have to shoot the ball above 45 degrees in order to make it go high and not too far. Alright, so this is the horizontal, and let's say this is about 45 degrees. I need to shoot just above 45 degrees in order to go in. So here it goes.
Alright, I'm going to shoot the ball a little further back now. I'm going to release a shot at an angle slightly below 45 degrees so that the ball can travel further in the X direction. But I'm not going to let the ball go too low either, because gravity is always going to be pushing the ball down at a rate of 9.8 meters per second squared. And if I let it go too low, the ball's going to hit the ground before it even reaches the net. Here's a shot slightly below 45 degrees. I'll say, here's the horizontal, 45 degrees is about there. I'll release the ball about here. Okay. Yo, that was such a nice shot. Respect that.
Air ball.
It's because the air resistance. The wind's blowing it.
But the wind's a natural force. How are you gonna go against that?
Over the years, we've been coming with this technology to go against this natural force of wind. Basketball players are trying to play basketball, but they can't. The wind is pushing their balls away. So we put our team, our best team, and their thinking and their creativity into this important design, an indoor basketball facility for basketball players to shoot their balls and not have their balls blown away.
Alright, now that we're yours, start shooting here. Oh, sweet. Now that there's no wind resistance here, it went in. Yeah, becoming such a good basketball player too.
Yeah, maybe you'll be as good as me one day.
I don't know, maybe I'm better than you now.
What'd you just say?
I said I'm better. Now let's have a shootout to prove it.
I shoot first. Just gonna go in. 45-degree angle. No! I don't need to worry. There's no way you're gonna get it in.
Yeah, we'll see about that. About the right angle. About the right velocity. And shoot.
No one's ever beat me. You ruined it. Ah!